this is lesson 12. I will solve two-step word problems, including multiplicative comparison. So we've been talking about comparing things whenever we've been talking about our tape diagram. When you hear the word multiplicative comparison, you're talking about how many times greater something is. That's comparing using multiplication, like John's truck is 2 times as long as Gary's, or Gracie's hair is 4 times as long as Gabrielle's. That's a multiplicative comparison. So today we're going to be solving two-step word problems using the multiplicative comparison. We will not be using our journals today because we're going to be solving problems that are on our problem set. So we're skipping the journal today and we're going right to lesson 12 problem set. So I want you to go ahead and you're going to notice that this does not look like your lesson 12 problem set. However, this is the very first problem that's on your lesson set. So I know this looks like you're going to write this in your journal, but you are not. This is the first question on your problem set. So we're going to use the RDW process for this, and we're going to read first. The table shows the cost of party favors. Each party guest receives a bag with one balloon, one lollipop, and one bracelet. What is the total cost for 9 guests? So you're going to notice when you get ready to draw something, you can think to yourself, okay, am I seeing or hearing any comparative words? And I don't. I don't hear that the balloon was 2 times as much as the lollipop or the bracelet. And when I look over here, I see this diagram that tells me how much each of these items cost. So I want you to try to think about what you would draw. Then I want you to, so you can see here that, sorry, show just yet. You can see here that we have two tape diagrams. And the reason why there are two tape diagrams is not because this is a comparison, but it's because it's a two-step problem. So first of all, we've got to figure out how much was spent on one guest. So by taking the balloon cost, the lollipop cost, and the bracelet cost and putting them all together, I can see what the total was spent for one guest. So one guest was 73 cents. And then here you can just see I was just modeling 1, 2, 3, 4, 5, 6, 7, 8, 9 guests, and I want to see what would be the cost for 9 party bags. So if each bag was 73 cents, that would be 73 times 9. So over here I've added 26 and 14 and 33. This is where the 73 cents came in. And then I just used standard algorithm. 73 times 9 is 657 or 657 cents or $6.57. Then here is where I wrote my answer as a statement. The total cost for 9 party bags is $6.57. You could have drawn a different picture or a different model and still got the same answer. This is just one example. All right, let's look at problem 2. So problem 2 says the Turner family uses 548 liters of water per day. The Hill family uses 3 times as much water per day. How much water does the Hill family use per week? So when I get ready to draw my tape diagram, I'm thinking to myself, do I hear any comparison language? And the answer is this time, yes, I do. So I'm going to highlight this for you. I'm sure you already found it. But when it says right here the Hill family uses 3 times as much, that tells me that my tape diagram, I'm going to have to model 2 separate tape diagrams. And one is going to be 3 times as large as the other. So go ahead and try to see what you think that tape diagram would look like, a comparative tape diagram, and then see if you can figure out how much water does the Hill family use per week. If you're having a little trouble getting started, you can stick with me and I'll show you what to do. Okay, so first of all, you're going to notice, I'm going to narrow this down a little bit, you're going to notice that here's my comparison tape diagram. This is how much the Turner family used. I didn't label that, but I could. Let's get off highlighter a little bit. So this is how much the Turner family used, and then this is how much the Hill family used. So the Turner family used 548 liters, and the Hill family used 3 times as much. So you know that the boxes are the exact same size. This is just 3 of those same size. And here's what I'm trying to figure out, how much that is all together. So this would be 548 3 times, or 548 times 3. So using standard algorithm, you get 1,644 liters. Now I'm going to write my answer as a statement. It says, how much water does the Hill family use per week? So this is how much the Hill family uses in one day. And I had to multiply that times 7 because there are 7 days in a week. So the answer is 11,508 liters. I'm sorry, it was a two-step problem. Now I'm going to write my answer as a statement. The Hill family uses 11,500 liters, 508 liters of water per week. That's why it's always important to do this statement because when you go back and you're like, per week, that helps you go, oh, that's not the right answer. Let's move on to problem number 3. Jaden has 347 marbles. Elvis has 4 times as many as Jaden. Presley has 799 fewer than Elvis. How many marbles does Presley have? So, are you hearing any of that comparative language? I heard this, 4 times as many is comparative language, and I also heard 799 fewer than Elvis. And you'll also notice that this time we have 1, 2, 3 parts. So when I model this, I'm going to have 3 separate sections for my tape diagram. See if you can figure out what each of those sections would look like and then come back and we'll look at it together. All right, so hopefully you came up with something like this. So you can see here Jaden has 347 marbles. And here's Elvis. He has 4 times 3. So notice these boxes are the exact same size because Elvis has 4 just like Jaden. So that's why these 4 boxes are very similar in size to Jaden's. And then it said Presley has 799 fewer than Elvis. So if this is how much Elvis has, the exact same size, and I know that Presley has less, this space would be 799. Okay, so first of all, I would want to figure out how much Elvis has. And you can see I already have the answer up here, but I had to figure that answer out. I had to solve by doing 347 times 4. And that gave me 1,388, and that's where this came from. So this whole diagram is 1,388, and this is 799 less. That tells me that I'm going to use subtraction. Now, I used a little bit of a different strategy here. I knew that 700 was really close to 800, so I subtracted 800 and added back 1. But you could do the same problem just by using standard algorithm. You could say 1,388. Hold on just one second, let me get my pen ready. Let me get my pen. So you could do 1,388 minus 799 and get this exact same answer. You can see that I cannot subtract in the 1, so I have to decompose in the tens, and that gives me 18. I cannot subtract in the 10, so I have to decompose in the hundreds. That gives me 17, and I cannot subtract in the hundreds, I have to decompose, and that gives me 12. So now it's just simple subtraction. I get 9, 8, and 5. So you can see it's the exact same answer, but I will have to say this was probably more work than this. This is just, I just took away 1 too many by subtracting 800 when I was really taking away 799. So I just added 1 back and I got the same answer. All right, so when I write it as a statement, Presley has 589 marbles because that's what my question is. All right, let's take a look at problem 4. Now, problem 4 is going to be a little bit tougher because it's going to ask us to actually write an equation and write a value. So it says, write an equation that would allow someone to find the value of r. Before I can make my equation, I have to kind of analyze this diagram. And I can see that I have 3 times 1,137. Then I have this second diagram here that's less than this. It's actually 239 less than this. So if I'm trying to solve for the value of r, this will be a two-step problem. Okay, the first thing I would have to say is my equation would be 1,167 times 3, because I would have to multiply this together to find out what the total was of this first diagram. Then I would want to subtract 239 from that total, and that would give me the value of r. Now it says, calculate and solve, write your answer as a statement. Okay, this is the same thing. Okay, we didn't solve for R yet. Now, it says write your own word problem to correspond to this tape diagram and solve. So we have to come up with our own word problem here. So I've got something that is 3 times this amount of 1,167. And then I have this other something that's 239 less. So I'm thinking to myself, what could be 1,167 times 3? So what if we wrote a story problem about a school could have 1,000 kids. Um, yes, I know. So let's say that, let's make this one about Audubon. So Audubon Elementary School has 1,167 students. By the way, we actually have less than that. York wants to give 3 pencils to every student. Because I've got to think, I'm trying to think ahead. He wants to give 3 pencils to every student. So here's a I've got to think of something like 239 left. So I'm going to say, Mr. York wants to give 3 pencils to every student. He buys a box of pencils, but he needs, or he has 239 pencils fewer than he needs. How many pencils does York have? If I were pretending that I was trying to solve this problem, so I would draw the same tape diagram because he wants to give 3 pencils to every student. So if there's 1,167 students, then that would be, here would be enough to give everybody 1 pencil. Here would be enough to give everybody 2 pencils. Here would be enough to give everybody 3 pencils. So let's solve to figure out how many pencils Mr. York needs altogether. So that would be 1,167 times 3. Just using standard algorithm here, you can see I have 21, 18, 19, 20. So that would give me 20. 3 plus 2 is 5. 1 times 3 is 3. So he needs 3,501 pencils. But it says here that his box of pencils has 239 pencils fewer than he needs. So that means I'm going to take away 239. So I've got 3,501 minus 239. And let's see how many pencils he actually has. So I cannot subtract here, but when I go over here, there's nothing. So I decompose this 100 to 4 hundreds and 10 tens, but I still need some ones. So I'm going to decompose that 9 and make this 11. So 11 minus 9 is 2. 9 minus 3 is 6. 4 minus 2 is 2. And 3 minus nothing is 3. So let's think about, does this make sense? Does this sound like 239 pencils fewer than 3,500? So I could just say, Mr. York has 3,262 pencils. I believe that's all. Yes, that's all of the problems that are on your problem set. I bet when you do your exit slip, you might have to write your own problem. I don't know. You're definitely going to have to solve a problem. So if you get stuck, come back and relook at this problem set. If you need to re-listen to part of this video, please do.